Hi, welcome to a new video. We're in Unit 1 still, solving linear equations on Lesson 2. And since this is Lesson 2, if you haven't already checked out Lesson 1 for this unit, you might think about going back to it. It was some pretty simple stuff though, so you might be able to get away with skipping it. Just watch the video, I guess, and see if you're lost or not. So this video is going to be solving two-step linear equations. So there's a little bit more complexity to it than what we did in the last lesson, which were one-step equations. But because we already kind of got a foundation of some skills in the first lesson, we don't have to focus so much on the foundation as much as building off of what we did and say, okay, how does this apply now to something more complicated? And that's actually a lot of what math is saying, well, we've been doing math, right, since we were old enough to start counting. How do we take what we know and add a little bit more complexity to it? So let's give this a try. The very first thing we want to do here is warm up. We want to get our brains in a math mindset. And so I've got three problems here that are relatively simple. They are attempting to get you to think about order of operations, which you'll see why that's going to be important in a little bit when we start looking at our problems for today. So if you haven't already, you can head over to my website, link in the description, and print off a notes page that has all of this written down for you so that you just have to fill it out. If you don't want to do that, grab a sheet of notebook paper and write stuff down as I go through the video. But either way, go ahead and pause the video and try to do these three problems and then press play when you're done, and we'll see how you did. Alright, so order of operations, you might have heard of a mnemonic device called PEMDAS, P-E-M-D-A-S, or perhaps the phrase is what you remember, please excuse my dear Aunt Sally. And that is a mnemonic device we use pretty commonly to talk about order of operations. The P stands for parentheses, we do parentheses very first, or other grouping symbols very first. E stands for exponents, so if we have any exponents, we do those next. And then M and D stand for multiplication and division, and then A and S stand for addition and subtraction. And so the thing that we want to really cement in our minds is this idea that when things are being multiplied together or divided together, there is a connection between them that weighs more than addition or subtraction. It's a weightier connection. What I mean by that is on this first one, we have a 4 times 5, and then we have a minus 3. And so this connection between the 4 and the 5 with multiplication is stronger than what's happening with the minus 3. If we think about it like that, it can make it easier to tell what you're supposed to do first. We are supposed to do 4 times 5 and then subtract the 3. So we do 4 times 5 is 20, and then 20 minus 3, which is 17. And that would be our answer. You get a different answer if you do it the other way around. If I do 5 minus 3, I get 2, and then I times by 4, I get 8. So we have to have a way that we all are going to do this to get the same answer. That's why this is the accepted way of doing it, and you don't get to just make up what you want to do. Sorry about that. So the same thing is true for division. Multiplication and division have the same kind of weight, and very rarely actually from here on out will you see many division signs. Kind of regret putting this one in here because normally it's written as a fraction instead. So it actually would be more likely that you would see this written as 8 over 2 to show division. And to me that makes it even easier to tell that the 8 over 2 is supposed to happen before you add the 7 onto it. But either way, understanding that division has to come before addition means that I'm going to do 8 divided by 2 first. So 7 plus 4, and 7 plus 4 is 11. And then this last one, parentheses are supposed to be an eye catcher. It's supposed to be in math, it's supposed to be do this thing first. Take care of what this is. Try to get rid of those parentheses so that you can do the other things around it. So we have 5 minus 9 here in parentheses. So whereas normally we do subtraction last, we're going to have to do it first because that's the operation inside the parentheses. Now, if you are familiar with the distributive property from pre-algebra, we could use the distributive property if we wanted to. And we should get the same answer if we do that correctly. But I'm just going to say, all right, parentheses, 5 minus 9 is negative 4. So I'm going to do 4 times negative 4. What's kind of weird is a lot of times we will put negative numbers in parentheses still. Part of that has to do with when we type things into the calculator, how we need the calculator to understand that we're talking about a negative number. And part of it, I think, just has to do with how nice it looks. Like not having parentheses here and writing a multiplication symbol and a negative sign next to each other, gives me the heebie-jeebies. So those parentheses don't mean necessarily do this first. It means, hey, this number together is negative 4. And so now we're free to do our multiplication. 4 times negative 4 equals negative 16. Now, what does this have to do with solving two-steps equations? I'm glad you asked. Real quick, let's remember something from last lesson. We talked about the algebraic properties of equality. These properties say that we are allowed to add things to both sides of an equation and have it still be the same equals relationship. We can subtract things or multiply things or divide things. As long as we do the same thing on both sides, it's okay. That our equation is still an equation. It's still a true statement that the left side equals the right side. So for our one-step equations that we had last time, we were able pretty easily to work through the mental math of what the answer would be. But as soon as we start adding something else to it, another step, it becomes more difficult. The more things you have to keep track of in your mind at the same time, the more likely it is you'll lose track or make a mistake or things like that. So these first two equations that are on my screen are one-step equations because we only have to do one thing to solve. And if I'm using the algebraic properties of equality on this first one, it's 3 times x, so I want to divide both sides by 3 and get my answer, which is x equals 4. On the second one, since it's x plus 6, I would subtract 6 over to the other side and get x equals 5. But if I look at this last one, can you tell why this is a more complicated equation? There's actually 2 operations happening over here on the left side to x. And order of operations is going to play a part in how we decide to do this. There's a 4 in front of x that's being multiplied by x. And that 4 is going to move to the other side using division. The negative 5 also needs to move away. And that's going to require us adding 5. The question is, which of those do we do first, or does it matter? And I hate to break it to you, but it absolutely does matter. And it has to do with when we are adding something on both sides and when we're dividing by something on both sides, and the way those work. So when I add something on one side or the other of an equation, like if I add 5 here and I add 5 here, I'm choosing to write that add 5 under the minus 5, but another way that I could write this is I could leave a space right here so that I could say I'm going to add 5 at the end, add 5 at the end. And it's just that we get to choose to do negative 5 and plus 5 together, so those cancel out and we're still left with 4x. If I instead decided to divide by 4 first, if I divide all of the left side by 4, that's going to look like this. If I do that right away, if I divide all of the right side by 4, that's going to look like this. So there's a couple problems here. One, the right side, 15 divided by 4, is not a whole number. Sometimes we can't avoid fractions, but if we can avoid fractions, we definitely want to. So that's one reason dividing by 4 doesn't necessarily seem like the best option at the beginning. And then secondly, dividing 4x and minus 5 by 4 means both of those things have to get divided. The same is true when we use multiplication. If there's more than one thing on one side of our equation and we're choosing to multiply, we have to distribute that number to both things. So because of this, we create kind of a special order of operations for solving equations that's actually backwards from what we would normally do with numbers. That if something is being added or subtracted next to x, we want to move that first and save the thing that's being multiplied or divided next to x as last. Because again, think of it like that relationship is weightier. So having 4 times x, those two things stick closer together than the minus 5 does. So we're allowed to move the minus 5 first, and then we take care of the 4 after. It's a little tricky, and that's one of the reasons why practicing is so important, where you're able to tell pretty quickly if you're doing it right. Because the hope would be that with enough practice, your instincts would be correct as far as what you choose to do first. If you're not doing enough practice to know when your instinct is right, then you don't know whether or not to trust your instinct on what you should be doing. And so that's a problem, obviously. So you want to do practice with somebody or with answers nearby so that you can really figure out, okay, is what I feel like should happen actually happening? And if not, how do I make the feelings be right? I know it's kind of weird to talk about feelings in math, but that's really what we've been doing since we were itty-bitty kids, is we are counting, and that counting becomes something, those numbers become something that we know inside of us, right? Not really in our heart, in our brain, whatever you want to call it, but there's a point at which you stop having to pay attention to counting. The same is going to be true here. There's a point at which hopefully we don't have to pay a ton of attention to what we're doing when we're solving equations, because it's just second nature to us. But we have to do a lot of practice to make sure that that happens. All right, so to give kind of my best summary for how is it that we choose to do things in an equation, what's a kind of universal rule, hopefully, that I can use to know what to do, is you want to think about x like it's the center of what you've got, and everything on the same side of x is surrounding it. And the things that are the farthest out from x are the things we're going to deal with first. So kind of I mean that in like a literal distance sense. So if x is my center here on this equation, then the 4 is closer to x than negative 5 is. So if I take that negative 5 and move it away, then all of a sudden 4 is the closest thing to x. So this is one kind of strategy that you can use that should also help once we get to more complicated things as well. That we want to work from the farthest things from x first into closer and closer to where x is. So I'm going to add 5 to both sides, which I guess I don't know if we actually, did we solve this on the previous slide? That was 2 minutes ago, but I don't remember. And then we would divide both sides by 4. And notice how I'm showing my work, and that is going to let somebody else looking at this hopefully follow along and maybe learn from what I'm doing. Or if it was my teacher that was looking at it, then if I made a mistake somewhere, they'd be able to tell where that mistake is. That's not to say that you aren't capable of adding 5 and then dividing by 4 in your head. Lots of people are capable of that, but your teacher can't read your mind, and so they don't know if you just put an answer, if you guessed, if you copied off of somebody, which of course you didn't copy off of somebody, that would just be rude, or if you got it wrong, they don't know why you got it wrong. So make sure you're showing your steps. It's super helpful. All right, let's do some examples of these. We've already technically solved one together, so we're going to solve a few more together, and I'm going to try to mimic for you what you should be doing, and also try to think out loud for you so that you know kind of the thought process that's supposed to be happening. So we've got 7x plus 9 equals 44, and that looks a lot like what our previous example looked like, our very first two-step equation that we saw. So we have this idea that the 7 and the plus 9 both need to move away from x, so that x is by itself. So choosing which of those is going to happen first, or another way of thinking about it is choosing which should happen last, is really important here. This 7 that's in front of x, anytime you have a 7x like this, that they're right next to each other, that 7 is the very last thing that you want to move. So I'm going to subtract the 9 from both sides first and get 7x equals 35. And then I'm going to take that 7 and divide it on both sides. So you can see that in both of these cases I'm using algebraic properties of equality because I'm doing the same thing on each side of the equation. And I'm also showing my work and making it really neat, boxing my answer so that anybody looking at it can be like, oh, I can see exactly where your answer is. Especially if you have messy handwriting, that can be super helpful. So Let's look at B. 2y minus 1 equals 7. What letter is being used in these equations doesn't really matter. I personally, and most math teachers have a few letters that we prefer over others. I honestly would rather just use x all the time, but I know that that's not helpful to have you be stuck in that rut as well. So y is also a nice variable. We do avoid certain variables because they look similar to other things like numbers, like s looks like 5, especially my s's and 5s look similar. But anyway, it's just the same as if we had x. We're just saying y equals something instead of x equals something. So again, I look at this and I have to decide, what am I going to move first, the 2 or the minus 1? I'm going to choose the minus 1. And by the way, if at any point here you're like, well, I think I got the hang of this, you should definitely either work ahead, and then whenever I catch up to you, you can know if you're right or not, or pause the video and work it out and then continue the video to see if you're right. But it's actually, as long as you're not annoying to your teacher about it, it's actually a really good skill to develop where you are listening still to what's being said, but working ahead to see if you actually understand what's happening. Now, one of the tricky things about math notes, I know this happens in mine a lot, is usually there are tricks that are introduced along the way. So it may be that you can already, if you printed off the notes page for this, you already see the next problem, and maybe there's a trick to it that we haven't talked about. So you might get hung up and feel frustrated about that. You'll just need to be patient and wait for me to get there, which is going to happen really soon. See, these look different than the ones before did, and that's fine. It may be that if you look at these, you might be like, oh, I think I know what to do. And that's great. That is a math kind of mind at work to see if what you already know, if you can apply it to kind of a new situation. That's a great skill to have. But I also want to encourage you not to be super frustrated if you don't know how to do these yet, because they're a little different. And so you should know how to do them after we go over them, but not necessarily before. So if I have 3 times and then a minus 2 is in parentheses equals 12, and I want to solve this, there's 2 ways I can go about it. And one of those is using the distributive property, which you probably learned in pre-algebra. And that's where you say this 3 is multiplying a and negative 2. They're both going to get that 3. So you multiply them both, and then you don't have to have the parentheses anymore. That's one way to do it. The other way is to kind of look at both sides of the equation and decide if it would be helpful to divide by this 3 initially. So earlier I talked about when I divide on both sides of my equation, I have to divide the whole side by whatever it is. That's why we said it wasn't the best option before. But here, the thing closest to a is actually the minus 2 because of the parentheses. If we knew what a was, we would do that minus 2 first and then times by 3. So working backwards, it makes sense actually to divide by that 3. Now here's a tricky thing that I think can be hard to grasp. When I divide this left side by 3, these 3's cancel out, and nothing actually happens to the a minus 2 inside. It just gets to be a minus 2 now without parentheses. And I think it's really cool that that's the way this works. It makes it really easy. The times that I don't recommend doing this, dividing by 3 first, and instead doing the distributive property, would be if when you divide by the number it gives you a fraction, because then we want to just wait as long as possible to get a fraction. So distributing would actually make that happen later on. So now that that 3 is gone, I can take this minus 2 and add it to both sides. And if this is confusing to you, definitely feel free to leave a comment and I can try to do a better job of explaining. Or look at what we did on some of the previous problems and look at how this problem looks and see if you can understand what's the difference here. Why would we do this one different than what we did before? What do you notice that is very different about it? And it's the parentheses that are making the big difference here. So here our answer is a equals 6. And this next one, may look intimidating because of this fraction, but again, we want to think of this n divided by 2 as being kind of stuck together until the very end. So that 6 is what we want to move first. So I would subtract this 6 because it's a positive 6. I'm not sure what happened with my subtraction sign there. Subtract 6, which gives us n divided by 2 equals 4. And then remember from the previous lesson how we fixed the fact that there was an over 2 or over whatever, is we use multiplication, because this is just saying n divided by 2, so we need to multiply both sides of our equation by 2 so that it cancels out. And that gives us n equals 8. So that's our answer. Pretty cool. Now it's your turn to try. These 4 problems are going to be really similar to what the 4 problems we just did, and if you need to look back at those examples as you work through them, then that's perfectly fine. That is a math skill, to be able to look at a problem that's similar and to be able to mimic what's happening. If you just start it but get lost and have to wait for my explanation, that's fine too. Just at some point, hopefully, you need less and less help as you're doing these problems. So pause the video, see what progress you can make, and then start the video back up and I'll work through them with you. Okay, so on this first one, there is a little bit of difference here, that our x is on the right side of the equation. I don't know if I'm mirrored or not. X is on the other side of the equation from what it has been. But that's okay, we're still going to move things away from x. There is actually a property that we can use where we just switch the equation around. If it would make you feel better, you can just say, I would really rather this be 3x minus 7 equals 2. You just pick the sides up and swap them, and you're allowed to do that. So if that makes you feel better, go for it. But I'm not going to do that. I'm going to pretend that didn't happen, and I'm going to work with the original equation. So this minus 7 needs to go first by adding 7. So 2 plus 7 is 9. And then we just drop down the 3x, and then that's our next thing we need to do. That 3x says, hey, we need to divide both sides by 3, and 9 over 3 simplifies to 3. Now a lot of these have been giving us some really nice whole numbers, in other words, not fractions. Sometimes our equations give us fractions, and we just kind of have to live with that. Fractions are a thing. In fact, in the real world, fractions probably happen at least as often as whole numbers. If you've ever tried to measure a piece of furniture, then you probably are aware of how infrequently it's a whole number of inches, for instance. Okay, anyway, B down here, so this has parentheses. You're welcome to distribute and try to do it that way. Or if we say, okay, well, 36 divided by 4 is a nice number, we could just divide both sides by 4. So that cancels these 4's out. 36 divided by 4 is 9. And then we write m minus 5. And now I'm going to get rid of the minus 5 by adding 5 to both sides. So 14 equals m is my answer. Let's look at part C. So here's the fraction again. We remember we want to save the y over 5 for last. I'm going to subtract this 1 over. And this is bringing up our positive and negative skills. And so if you are struggling with how to add and subtract positive and negative numbers, that's definitely something you should work on. And as soon as I've got a video to help with that, I will link it in the description, but that might not be right away. So you can check it out, or maybe a little thing will pop up at some point saying, hey, I got a video that will help you with this. Either way, right now, -2 plus -1 is the easiest way to think of this. That the other way is to think -2 minus 1, that's fine. But I just like to think of this like it's always addition. And then the rules are pretty simple. -2 plus -1, they're both negative, so they become more negative. You add them together, but you keep the negative sign, which gives you -3. And then this 5 on bottom, we need to multiply both sides by 5 to get rid of, so y equals -15. Ta-da! And finally, 1 plus 4x equals 17. So we want to look at what's farther away from x, which is this 1. Let's subtract that 1 over to the other side. And then divide both sides by 4. And get x equals 4. Alright, how'd that go for you? Good? Bad? Somewhere in between? Feel free to leave me a comment and let me know how things are going for you. Check out my website, which is on the screen, or if you would like to go to the description and go to actually the web address for specifically this lesson, I've got some resources on there that you can use. This is all going to be a part of my Algebra 1 online course that I'm offering this fall, and hopefully many falls in the future as well, that if you would like to be able to actually interact and get help, there are options for that. You just need to go to my website, KStevMath.com, and get signed up for that. I'm really excited about it because I love teaching and I love interacting with students, and knowing that I am helping people who might otherwise not have a great math experience have a hopefully great math experience. So thanks for watching, and I'll see you in the next video, but make sure to subscribe, maybe do a like, comment, tell me your favorite color, because I didn't leave you a challenge problem here. I'll try to make sure to put a challenge problem in the next one so you have something to comment about. Thanks. Bye.